And welcome back to my channel. And today we have a sort of teardown of a UK mains socket tester. Probably quite an old one, but there we are. So, not wasting more time, let's get in there, let's see what it does. Right, we have some dodgy connections here, which I'm not going to show, but it's crock clips and bits of rubbish. So what we're going to do is we're going to turn it on, and this is wired as it should. So there we go, all three are lit, so we're happy. Right, now this is the neutral. If I take the neutral off, what we're going to see now, right, so there you go, two on the out, two on the right, one off on the left, no neutral. So it did what it said. Right. What's next? Live and earth reversed. So there's the live going onto the earth pin. And there's the earth going on. Get back a bit so you can see it. Right, so this is live and earth reversed. Hope don't blow a fuse. Live and earth reversed. We just have the one on the right lit like it says. Right, what's next? Put the earth back where it belongs. And we swap over. Oh, live earth, live and neutral is swapped. Need to get the earth on. Move it about a bit so it's back in picture. It's not, it wants to go where it wants to go. Alright, I should have made a better thing for this, but this is just a spur in a moment one. So here we go, this is going to be live and neutral reversed, which it says. And then for the last one, we're going to remove that. And we're going to swap live and neutral back to where they should be. So this is just as it is, but with no earth. Power back on, and then we go. Two on the left, none on the right. No right one. So that's right. So this is functioning as it should. If I put the earth back gingerly, you'll see that one lights back up again. Right, I'm going to turn that off now and disconnect this rather dangerous piece of wire. And that's what you can see here is, you know, it's a bit of mains cable with a plug stuck on the end. Some bare wires going into a connector to the lead that lays on my desk that powers the light on the scope. Right, so that's gone. That's back in. That can go back in the drawer. Let me get thrown over there. Right, so this was made by, I don't know how old it is. Maestro Lite Limited. See instructions. Well, I ain't got any instructions. I found this in a box downstairs in the understairs cupboard, in a box full of light bulbs and fuses and other things. Didn't even know I had it. And there it goes. On the back it says, Do not open. Made in England. And the name. So, what are we going to do, you ask? Well, I think the first thing to do, get the focusing right. And of course, we're going to open it, see what's inside. If you haven't already subscribed, can I take this opportunity to say, please hit the subscribe button. It costs nothing and it will help my channel to grow. The more subscribers, the more YouTube algorithm will look at me favourably. Thank you. I think it's the wrong size screwdriver. There we go. Is that coming off? Nope. Yep, it is now. And there we have it. For all those who want to pause the video and have a go at reverse engineering. Can I get it even bigger in shot? Yeah, you might have cut problems reading the colours. 3 neons, 2, 4, 6, 8 resistors. So there you go. So the live pin, neutral pin, and the earth pin comes up on this bit of green wire. So very simple. How does it work? And does it rely on something that is, I don't know if it's unique to the UK. Other countries might have it. Let's focus it back down there again. In the UK, our earth and our neutral are joined together, so they're effectively the same thing. And I think it's something that this relies on to work. But let's pop up the circuit diagram. Well, as you can see, it's a very simple circuit. And it does indeed rely on the fact that the neutral and the earth are at the same potential in the mains plug or main socket, as they're effectively shorted together. And so in the next sections you will see where the currents are flowing and why the lights come on. Here we can see we have the correct wiring, and there go the little electrons. They're off and they're running, and you can see as they hit the neons, they're happy and they light up, and you can see the current paths returning back via the kind of easiest route. As you can see, the neutral is broken, so let's see where the current flows and why particular neons don't light up. So they're racing through to the end. Very slow electrons in this demonstration here. You might notice the volt drop across R1 isn't sufficient due to the lower current to strike neon 1. The thing to remember here is the earth and the neutral are exactly the same potential, and so will attract the little electrons equally as good. So let's see what they choose to do. Again, the current through the resistor in parallel with the neon has to create a voltage high enough to strike the neon, or the neon just will not light. Again, remember, neutral and earth are at the same potential. So the live currents are going to try and get to both neutral and earth the easiest way they can. And so there you go. Neon 1 is the only one that lights up. Very simple circuitry. And for the grand finale, no earth. So you shouldn't have to guess where the currents are going to go this time. And the little happy faces of the neons when they're lit up. So here they go. As a test, I left one current path off. Can you describe it in the comments below? Well, if you like this video, you know, subscribe, it's free. I can't charge you anything. Wouldn't if I could. So, if you like it, you know, please click on the subscribe button, hit the like button, and click on that bell for more. You know it makes sense. And I'll catch you on the next one.